happy to be here and see a lot of familiar faces. A little bit about myself. I started in computer science education about 10 years ago, was a volunteer in the first cohort for the co.org CSF, was part of the writing team for the K-12 CS framework, started an organization in Texas to advocate for computer science, was a huge fan of microbit in the early days, and then now I'm at a company called Robotical. So this is going to be, as Peli says, about old school machine learning and artificial intelligence. We're not going to talk about generative AI or large language models in today's presentation, but really try to get to the underlying core principles that students can start to understand how these models work. And then unlike Josh, I don't have enough courage to do a live demo. Plus, I'm not sure you'd want to see me take a bunch of sample data. So I've turned this into a little bit of a pseudo workshop. When we get to that part of the presentation, you're welcome to join at the URL and kind of see some of the things on your screen that I'll be showing up here on the big screen. So we'll go over at a very high level. I've got 10 or 15 minutes and a very diverse audience of people. So just level set real quickly on what machine learning is. And then we'll go, for you that may not have heard of Teachable Machine, do a flyby on that and look at how we've incorporated at Robotical machine learning into our block-based editor. And then lastly, how then we can control a humanoid robot using some of these machine learning inferences. So really what we're talking about is deep learning, if you wanted to get really technical about it. So using neural networks to predict the outcome of certain guesses. And another way to explain this is really using classification models. So unlike large language models that are predicting a given text or a letter or a word or a paragraph, these models are only going to be able to predict what we've been able to train it on. So we have to give it labeled training data in order for it to know what objects are. And the way machine learning models work, as opposed to human programming, if I were to teach like an infant or a dog what an apple is, I wouldn't start describing the apple as a spherical thing that you hold in your hand. Maybe it's red, maybe it's green. I would hold it up and say, this is an apple, this is an apple, this is an apple, this is an apple, this is an apple. And then over time, we would then train the human or the dog to start to recognize what an apple is. But if I held up this, they would have no idea, because I'm not training them to learn what a banana is. And so machine learning models, classification models specifically, are like this as well. We have to train it to recognize or to understand each of the different objects we want it to understand in order to be able to make predictions. This is an example from the Google TensorFlow team. So TensorFlow, I think of it a little bit as a compiler. It's a framework that sits at a lower level that takes in the various inputs. For professional AI engineers, there are different stages here that you can then optimize, whether that's on the front end of getting the labeled data in a state where it's able to come in and be useful. There's a lot of work that happens here in the middle around model engineering and optimization. What we're going to do, though, is abstract this away and turn the middle part into a big button and start and focus mainly on the inputs and the output inferences and then what to do with that data. I find this really interesting, especially as we're talking about accessibility here a lot this week. How do machine learning models see and hear? Well, it turns out they see much like we see by detecting edges. And that's why camouflage works for us as humans. What camouflage is trying to do is prevent us from discerning where the edges are on an object. I also experience this sometimes when I'm looking at a news feed or something, and there's a really small image, and I can't quite make out what it is because I can't quite make out what the edge is in the image to then be able to determine what that is. So one of the things that AI engineers do then is apply filters to highlight edges and make those more prominent. We as humans also see these images up here as 2D. in an X and Y dimension. When we feed this into a machine learning model, we're going to take that X by Y and turn it into a 1-bit string of 1 by X. And so that's how the computer is going to see these various images as just a long string of pixels together, as opposed to a grid of pixels as we see it. On the sound side, you might be familiar with sound in the amplitude domain. So as we speak, the louder we speak, the amplitude adjusts up and down. But for machine learning, we actually take this out of the amplitude domain, use something called a fast Fourier transform to convert it into the frequency domain, and then now we have a picture. And that picture can be processed just like other images and pictures that a camera or eye may see. So sounds ultimately get converted to images that then get processed. So on Teachable Machine, just a quick show of hands, who's familiar already with Teachable Machine? Well over half. So this is another website-based tool from Google. It's a fantastic introduction, and this is where I see a lot of educators starting with AI and machine learning. The link is there at the bottom, or if you just search Teachable Machine, they offer 3 different types of models, images, sounds, and poses. We don't actually take advantage of the poses, but if you create an image or a sound model, you can then export that out of Teachable Machine, and then we have the ability in our software then to take that URL that is generated in Teachable Machine and then paste that right into our block-based editor to be able to use in the code. If educators are not already using Teachable Machine, then we can start from scratch, pardon the pun, directly in our software at robotical.app. So if you want to go to that and kind of follow along, either now or later, you're welcome to do that. So we have added, so we're a Scratch fork, and we treat machine learning models very similar to how Scratch treats sounds. So just like there's a sound tab, and then you have various sounds saved in your sound library, we have a machine learning tab that we've added to our fork, and then you can have multiple machine learning models saved on that tab. We can generate 3 different types of models using either the camera in the host device or the microphone in the host device, very similar to Teachable Machine. And then we have a new product called Microbit, or not Microbit, called COG. Sorry. It's kind of like a microbit. It's a microbit for younger kids. It's called COG to introduce physical computing at a young age. But similar to microbit, it does also have an accelerometer, and so we can use that accelerometer to then capture motion data and gestures and use that to train a gesture model. So we have 3 different modes here that we can generate the model. And then, as I said, we're going to abstract away a lot of that engineering that takes place in the middle. So when we go to the machine learning tab and we select what kind of model we're going to create, we're going to then define our classes. So classes are the various types of objects. So in this case, one class could be an apple, one class could be a banana. For sounds, it could be a clap or whistle, or it could be individual words and voice prompts. And so we can turn Marty into a voice prompt activated robot. So as we define the classes, then we have to teach the model what those sounds, images, or gestures are, including in this case what background noise is. So what is quiet? Because the model doesn't even know what quiet is. So we have to teach it everything. Once we have defined our classes, collected our sample data, then we hit the magic train button, goes off to the cloud, does 100 epochs, which is 100 iterations to generate weightings for a neural network. We'll get a loss plot, and we'll show the students how their model is honing in on the weightings. Then you can actually run it, very similar to Teachable Machine. You can run it in the tab to test to see how the model is working. If you are happy with it, then just hit the save button. And once we have our model saved, then we go back to the code tab, and we have a dedicated menu for machine learning that then gives, now we're kind of back into traditional block-based coding domain. So we have a variable for the sound label, the image label, or the gesture label, and then we can use that variable just like we would use any variable in our program. We have event handlers, we have conditionals for Booleans. The only kind of tricky thing, and if somebody's got a more creative way to do this, is we have to execute the load block first in order to be able to bring the class names into all of the other blocks. Now, if you're a student and you don't want to do that, you want to have everything happen at runtime, then you can use the variables because you define the classes, and so you can do the logic with the class names yourself. But any of the drop downs that are inherently in the blocks, the only way we could figure out how to do that was to actually execute the load command first, and then that brings in the class names. So maybe not a real life example, but something that's fairly easy to live with. And then you can pair Marty the robot, which probably most of you have seen out at the table, and we can use all of Marty's outputs then to respond to various prompts that we've trained in the machine learning model. So as I mentioned, we could do a voice-activated robot and have Marty walk or wave or kick based on voice sounds. I did a really creative, I just had some construction paper at my desk, and so I trained the model to recognize colors. And then I used Marty's voice commands and held up like a flashcard, and then I would hold up the flashcard and Marty would tell me what color I was holding up. Not because I had given a certain value to that color, but because I had trained the robot or the model to recognize those colors over time. Again, we are using, at the moment, the camera and the microphone in the host computer. We are looking at how can we bring more of that to the edge and put maybe a camera or a microphone on Marty or a different product to kind of be less reliant on the host computer. And then here's just some more information. If you wanted to try this on your own, we have step-by-step user guides as well as some student-facing tutorials. Thank you very much. I'm happy to take questions for a few seconds.
Thank you.
Good. 15 seconds.
Thank you.